Morning everyone, I'm Ming. Thanks you all for being here. Today I'm going to talk about 4 Armyworm-Associated gut bacteria modulate plant defense responses. Before we go through today's paper, I'll give you a short talk to recall your memory about my present from last time. Under insect feeding, plant will have 2 hormones to regulate the plant defense. When the parasitic insect comes, plant will go through SA signaling pathway, and the chewing insect will lead to the J signaling pathway. That is the way plant against insect feeding. However, insect also have its way to avoid plant defense. During the feeding, the symbiotic microbes will be secreted on the plant's leaf with insect regurgitant. So what is regurgitant? Just like this. The regurgitant is the oral secretion secreted by the insect from its gut or the salivary gland. According to this paper, scientists will use antibiotic to eliminate bacteria in the oral secretion, that is the regurgitant from the insect. And with the antibiotic treatment, you can see there's few bacteria in the oral secretion. So in the following slide, I will use AB plus to represent the antibiotic treat, and the AB minus to represent the non-antibiotic treat. In this paper, scientists investigate the fall armyworm. Fall armyworm is a pest which prefer maize as a damaged plant, and the fall armyworm can not only eat leaf on maize plant, but also eat sorghum and the corn. You can see on this picture. This is the damage that fall armyworm caused, and you can see this damage is very seriously. In this paper, scientists collect the fall armyworm from field, then do the AB minus and AB plus treatment on the caterpillar. Then they do the infestation on tomato and maize. Also, the scientists will collect the regurgitant from the caterpillar, then treat on the plant, tomato and maize wounding. By this result, we can see when the tomato was fed by the caterpillar, the AB plus treatment will show higher PPO activity than the untreated caterpillar feeding. And there's the same pattern when the scientists treat the plant with wounding and regurgitant. By this result, scientists found that regurgitant from caterpillar can suppress the tomato defense. However, in maize, the scientists measured the maize protease inhibitor gene, and they found that there's no significant difference between AB plus treatment and untreated caterpillar feeding. And by this result, scientists know that regurgitant from caterpillar didn't affect maize defense. To know which bacteria is the one will affect the plant defense, scientists isolate the microbe from the regurgitant and measure the PPO, POX, and trypsin protease activity to symbolize the plant defense. By this result, scientists found that these 2 bacteria will suppress the plant defense in tomato. That is Pentoa annensis and Enterobacteriaceae 1. These 2 bacteria will suppress the PPO activity and trypsin protease activity, but increase the peroxidase activity. However, in maize, all the bacteria isolated will induce the maize protease inhibitor expression higher. This is the gene way to see what the pattern on plant defense. However, we have to know the phenotype of the caterpillar in this pattern. So in this experiment, scientists do 3 treatments on the plant. They use the individual bacteria isolate to treat on the plant's wounding and the media trade on plant wounding. Media is the buffer used for bacterial culture and the control. After treatment, scientists cut down the detached leaf and feed with the caterpillar. They measure the caterpillar's weight. By this result, scientists found that these two bacteria in tomato will lead to high caterpillar weight gain than the mediate treatment, which is similar to the control. But in maize, the caterpillar's weight gain is lower than the mediate and control. To see whether it is the Pentoa anitis is the bacteria will suppress plant defense, the scientists do a re-inoculation in AB plus treatment caterpillar. After re-inoculation, the caterpillar's oral secretion will be abundance of bacteria in it, and the scientists will use the caterpillar to feed on tomato and maize. By this result, scientists found that in tomato, when the Pentoa plus treatment will have lower PPO activity than the Pentoa minus treatment. However, in maize, there's no significant difference between Pentoa plus and Pentoa minus in maize relative expression. Plant and insect interaction is the war will never stop. According to this paper, microbe is the partner we will help caterpillar or insect to avoid plant defense. In the future, to study the plant-insect microbe interaction, can show this pattern more clearly. Thanks for listening.